In this example, we will find all real or complex solutions to the quadratic equation, the quantity 3y minus 5 squared equals negative 24. The first step in solving this equation is to recognize that there is exactly one variable occurring in the equation, and it is caught up in what is being squared. So when we're working with the equation, quantity 3y minus 5 squared equals negative 24, we can immediately apply the square root property. This property says if the quantity 3y minus 5 squared equals negative 24, then either 3y minus 5 equals the square root of negative 24, or 3y minus 5 equals the negative square root of negative 24. For both of these new equations that we've come up with, 3y minus 5 equals root negative 24, or 3y minus 5 equals negative root negative 24, there are two things we need to do. Isolate the y that's on the left side of each equation, and simplify the radical. Since the radical is isolated by itself on the right side of the equation, I think it'll be easier to simplify the radical while it's by itself before moving anything away from the y and trying to isolate the y. So we'll just work with the right side of the equation right now. So with the first equation, 3y minus 5 equals the square root of negative 24, the first step in simplifying the square root of negative 24 is to separate the factor of negative 1 from the factor of 24. So I'll rewrite the square root of negative 24 as the square root of 24 times the square root of negative 1. The reason for doing this is that we've now separated the real from the imaginary component in this number. Looking at the square root of 24, I can further simplify the square root of 24 because 4 is a factor of 24 and 4 is a perfect square. 4 times 6 is 24, so I could rewrite the square root of 24 as the square root of 4 times the square root of 6. And don't forget we also did have that factor of the square root of negative 1 also on the right side of the equation. Taking this a step further, the square root of 4 will simplify down to be 2. The square root of 6 cannot simplify because there is no perfect square that divides evenly into 6. And the square root of negative 1 will become I, giving us 2 times root 6 times I. It is more standard to write this with the I in front of the radical, or the other way to say that is that it is more common for the radical to be the final factor in that value. So we will write this as 2i root 6. Now it's important to recognize that I've only worked with the right side of this equation, and through all that work I haven't touched the 3y minus 5 on the left side, so I do need to take a moment to backfill all those 3y minus 5s on each of those steps of work. Now that we have simplified the radical, we can try to isolate the y. The first step in isolating y will be to add 5 to both sides of the equation, so we'll end up with 3y equals 5 plus 2i root 6. You probably noticed that I put the 5 in front of the right side of the equation as 5 plus 2i root 6, and not 2i root 6 plus 5. Again, it's more common to have the radical term last, so it's clear what is or is not underneath the radical. The final step in solving this equation is to now divide both sides of the equation by 3, giving us y equals the quantity 5 plus 2i root 6 all over 3. That was solving the first possible solution. The second solution comes from the equation 3y minus 5 equals negative square root of negative 24. I'm going to save myself some time in not having to redo the work I've already done, where I simplified that square root of negative 24. Through our work over on the left equation that we just solved, we know that the square root of negative 24 is the same thing as 2i root 6. So I'm going to make use of that fact and then rewrite the equation 3y minus 5 equals negative root negative 24 as 3y minus 5 equals negative 2i root 6. And we'll have similar steps here to also perform to finish solving this equation for y. We need to add 5 to both sides of the equation, so 3y will equal 5 minus 2i root 6. And then we'll divide both sides of the equation by 3 to isolate the y completely. So y will equal the quantity 5 minus 2i root 6 all over 3. You might also notice that those two solutions are nearly identical, except for the plus or the minus in the middle of the numerator. So if we want to save some time, we could write the solution set as the set 5 plus or minus 2i root 6 all over 3. You should also recognize that sort of statement, 5 plus or minus 2i root 6 all over 3, looks very similar to many of the solutions we obtained when using the quadratic formula.